Okay, so 15 is what we're going to work on here. All right. When you are doing two-column proofs, which most everybody that I've ever worked with considers the hardest geometry problems there are two-column proofs.
Mm-hmm.
Let's talk about your strategy. Okay? It's a good idea to work out your strategy in advance. In other words, if we're trying to prove that AL is perpendicular to ES, well, if we look at this thing, can you see where I'm pointing?
Mm-hmm.
If we can prove that that triangle is congruent to that triangle, that will be enough to prove that that's a 90-degree angle and that's a 90-degree angle, because we'll be able to say they're equal to one another. They're also a linear pair, therefore they have to be 90 degrees each.
Mm-hmm.
Okay? So to me, that's the first thing you figure out, is how I'm going to prove what they want us to prove. And then you figure out the statements and the reasons. But the ultimate way that I'm going to prove this is by proving that the triangle on the left is congruent to the triangle on the right. Now, let's look at those two triangles. What do we know about them? First of all, we're looking at a kite, and all of the given information is in the diagram. We know the two diagonals. Well, we don't know those form right angles. That's what we're trying to prove.
Mm-hmm.
But let's look at these two triangles on the bottom. Is there any way we can prove that those are congruent?
Yeah.
How? By which congruency theorem?
You can do SAS.
You could do SAS, you could also do SSS,
Mm-hmm.
right? In other words, we have a theorem that says that the diagonal, the long diagonal of a kite bisects the short diagonal. So that tells us that AB is equal to BL. Well, we also know that BS is equal to BS, so we have side, side, side. We also know that the long diagonal bisects this angle, so if we wanted to use side, angle, side, we could use that also. So that's the strategy we're going to use to prove everything. So let's go through the statements and reasons. Statement one is always what?
Given.
Okay, so whatever they've got here is a given, write as statement one. And then the reason is given. Statement two is what?
You could do BF is congruent to SB.
Okay. Based on?
Reflexive property.
Good. Statement three.
You can do either that A, B is congruent to BL, or...
Okay, well, let's pick one. There's definitely two different ways to do this, but you got to pick one.
Alright, I'll do AB is congruent to LB.
Okay, based on?
I have no clue.
Well, I don't know what the title of the theorem is, but it's based on the fact that the diagonals, the big diagonal bisects the small diagonal in a kite. And since they've told us that it's a kite, That's the big diagonal. That's the small diagonal. If the big diagonal bisects it, then AB is equal to BL.
Okay.
Okay, what's the next statement? Number 4, I believe.
It would be triangle ABS into LBS.
Good. What's the reason?
SSS.
Okay. Statement
Also,
5.
Can't prove it. Or no, I have to go.
If these two triangles are congruent, what is true about these two angles right
That.
In other words, angle ABS has to be equal to angle LBS. Based on what?
SSS.
Well, CPC.
Or CPCTC.
Yeah. Corresponding parts of congruent triangles are congruent. Well, these are the two corresponding parts of these two triangles. So we know that this ABS is congruent to LBS based on that.
Mm-hmm.
Statement 6.
AL is perpendicular to ES.
Not quite yet. First of all, we have to say that ABS and LBS are equal to or 180 degrees, right?
Mm-hmm.
Why? What's the reason?
Because triangles are equal to 180.
They're a linear pair.
Oh, yeah.
And that's different than the reason you gave. Okay? In other words, we've already proven that ABS is equal to LBS. Now we have to prove that they're each 90 degrees. Well, if I know that ABS is equal to LBS and that ABS and LBS are add to 180 degrees because they are a linear pair, that's the reason. And now statement 7 would say something to the effect that if they're equal and they're supplementary, then there's only one way that can happen, and that's if they're each equal to 90 degrees. I guess you would say something like the following. You would say ABS plus LBS is equal to 2ABS. You with me?
Mm-hmm.
The reason you can say that is by substitution. In other words, we've already said that ABS is equal to LBS. So clearly I can say that if I've now said ABS plus LBS is equal to 180, then I can say that 2ABS is equal to 180.
Okay.
And now finally, the last line, or the 7th line, I'm not sure where we're at, but if 2ABS is equal to 180, then ABS is equal to 90 based on the division property of algebra. In other words, you can divide both sides by 2. And finally, if ABS is equal to 90 degrees, then AL is perpendicular to ES based on There's some theorem that if two intersecting lines form a 90-degree angle, all four angles are 90 degrees, and they're perpendicular. To me, it's not I mean, I'm sure, do you have Jansak?
Mm-hmm.
Yeah. To me, it's not terribly important that you know the exact name of the theorem. What's really, really important is that you understand the concept of the theorem. You know what I'm saying?
Mm-hmm.
3 years from now, you won't know these theorems from Adam, the names of them. And it's not important that you remember them 3 years from now. What's important is that you remember that these two triangles are congruent because they have three sides that are the same. That's what's important. Whether you remember it as side, 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 that's not so important, just so long as you understand what the meaning of it is. Now, I know that these two-column proofs make that difficult because they make you give an exact statement and they make you give an exact reason. And the reason is usually citing one of those theorems. But I'm betting that even Jansak, if you didn't cite the exact theorem, but you cited the right principle, he would give you full credit. Yes?
Maybe.
Yes or no?
I have maybe. Sometimes he can get really annoying about knowing theorems.
I've heard stories about him for years. So
Yeah.
I know that that's true, that the more precise you are, the better off.
Mm-hmm.
All right. We only have 7 minutes, but we can get started on the other one. I have another student taking honors geometry from Jansak. I don't know if he's in your class or not, but very, very bright student. What are you currently getting in geometry?
I have a 79.75.
Okay, so you're close to a B. We can get you to a B. Trust me.
Yeah.
Even with the ANSAC, you can get to a B. All right, let's look at 14. What I want you to tell me before you give me a two-column proof is conceptually, how are you going to prove it?
I could do either angle, side angle, actually that, or angle, side angle, or angle, angle, side, maybe.
Yeah, you got a lot of choices here. The one obvious thing that stands out is these two vertical angles. I would definitely use that. Now, this side over here being equal to that side, not so helpful if you're dealing with these two angles.
Yeah.
That's going to eliminate side, angle, side, and angle, side, angle. However, what about these two sides here, TA and AE, and also RA and AC? If you could prove that those were congruent, there you'd have it, right? You'd have it based on side, angle, side. And you wouldn't even need to consider these opposite sides here. So is that a true statement? In other words, is side TA equal to side AE?
Maybe if A is the midpoint.
Is there a theorem that says anything about the diagonals of a rectangle?
Yes.
They bisect one another by definition, by a theorem, okay? Well, once you know that, then TA is equal to AE. And RA is equal to AC. So right there you have your side angle side.
Mm-hmm.
That's going to prove that this triangle is congruent to that triangle. Okay, give me the 5 reasons. What goes in number 1?
The given.
Okay, what about number 2?
Angle A is congruent to angle A.
It's not A. Angle A is this obtuse angle right there.
Oh,
So you have to
angle,
define it by 3 letters.
angle RAT is congruent to EAC or CAE.
Based on?
Vertical angles.
Okay. Next. 3.
TA is congruent to AE.
And on that same line, you could also say,
RA is congruent to AC.
and then the reason for that?
I don't know what theorem it is. I think it's theorem 8.6.
Well, I don't care what number it is. I don't even have the same number in my book. But the reason is that the diagonals of a rectangle bisect one another.
Mm-hmm.
And I'll bet you that if you put that as the reason, you will get full credit. The diagonals of a rectangle bisect one another. In fact, this would be the perfect test of Jansak. If you put that and he takes points off, I'd complain to the principal.
Okay.
In other words, if he really requires you to cite the precise theorem that says the diagonals of a rectangle bisect one another, I'd be disappointed. Because remember that in every geometry book, those theorem numbers are different. There is no master geometry book where all these theorem numbers are the same. So the theorem number is not the important part to remember. There is no standard there. The important part to remember is the principle.
Okay.
What's statement 4? It's actually, in other words, because I combined 2 statements in 3,
okay.
They probably meant you to make 1 3 and 1 4. The final statement is what you're trying to prove. And what's the reason for it?
SAS, congruency postulate.
That's it.
Okay.
So let me just conclude with saying that, to me, the secret to these 2-column proofs is to figure out in advance how you're going to do it conceptually.
Okay.
Not any other way, because it's really hard to figure out the order of the statements and the reasons until you figure out how you're actually going to do it. Once you figure out how you're going to do it, then it's pretty easy to go back and figure out what statement 1, 2, 3, 4, and 5 should be.
Yeah.
But that's absolutely the secret to them, is figure out how you're going to do it in advance.
Okay.
All right, Allie? All right. Well, you have a very nice Thanksgiving tomorrow.
You too.
And I hope Mitch and your parents, and I will talk to you next Wednesday.
Okay.
All right, Allie. Bye-bye.
Bye.